Okay. Hello, everyone. Good afternoon. So we will continue our study, okay, especially on chapter 7. And reminder for those of you who want to take the makeup exam, you need to fill out the form, okay? And the place is on TR Building 309. This Saturday, we will start from 10 a.m. Okay, start from 10 a.m. So better if you maybe before 10 a.m. you already arrive. Okay, arrive at the building. Okay. Yeah. You can go to my office to look. Okay. Okay. For those who are in a classroom, uh, you can check your last quiz, if you haven't taken. And for quiz, not the next quiz, for the chapter 6 quiz, we will have the quiz on uh, first week, okay, of January. Okay. Similar like last time, maybe only 3 to 4 questions. Okay. Okay. And is the QR code working now? Okay. Okay. So I think yesterday maybe the system not is in a good shape yesterday. Okay, to start our class, okay, let's begin with the feedback. Okay. Okay. So you have the region. Uh, you have the curves, square root of x and y equal x, and it is revolved, okay, or rotated. Okay. So revolve or rotated about the x-axis. Then the volume of the resulting solid is this integrations pi square root of x minus x squared dx. Okay, and this is false because what we need to look at is yeah, you can take it. You can take it. Yeah, yeah. And the problem here is uh, in the statement they are subtracting the radius. The problem is we need to subtract the area, not the radius. Okay. So the correct answer should be square root of x squared minus x squared. Or if we write down how it looks like in terms of the area, should be this should be the area. Let's say area 1 minus area 2, and then multiply with the height, which is the dx. Okay. So this is the area, and this will be the height. If you remember, this is the disk, right? Or we called it, this is the washer, or the disk with a hole. Okay, so it is false. Okay, I think You just need to be careful on the definitions. The next one is finding the area, or maybe find area between curves. Okay. So first, we can actually, if you are given these two curves directly, I think you can directly find the intersections, right? Because you have the x squared, the positive x squared, and then the negative x squared, which is the one is upwards and downwards. And I think you can just go directly to check the intersection, and you get at least the endpoint of the x, right? Okay. So not necessarily to draw the curves, but if you want, maybe you can have a better visuals. Okay. And you can check that the because it's a parabola, it's a symmetrical. You can just make it a 2 multiplied by the integration from 0 to 3. Okay. To simplify your calculations, and then you get the results of 72. I think you guys get a good job here. A lot of you get the correct answer. Okay, that's number 2. Number 3 is rotating the curves, the region between these curves. Okay, y equal x squared and x equal y squared. So you can use the dish method, rotate it to y equal 1. And the idea is still the same. You need to find or identify the radius. Okay, so the radius we'll have the outer radius, right? We have the outer radius, which is, let me write here, which is this one, right? And minus the inner radius, which is this one. And we know that this is 1, right? The height for the line is 1, right? Y equal 1. So the radius for the red color here, the radius is 1 minus this one, x squared. And the other one is square root of x. So 1 minus square root of x. So that will be our radius. Then we can write down the formula, okay, using the disk or the washer, because it has a hole. So pi integration from 0 to 1, that's the intersection between those two curves. And then the first one, the outer radius, 1 minus x squared, then squared. Okay. This is just like a circle, right? The area of circle. And then the second one is 1 minus square root of x, and then squared. Okay. The radius squared, and then the x, the height of the disk, right? You can formulate and calculate those. We get that it is 11 over 30. Okay. Okay. Yeah, the problem here is, I think, maybe careful in the calculations here. Okay. But in case in your exam, writing this down is already a half, okay, already half or 60%. Okay. You guys did around here, did a correct job, adding more 20 to 30, and getting the final answer will be 100%. Okay. So writing down this part for the first part here is already at least 55 or 60%. Okay. Okay, that is our feedback. Okay. Okay, the next is our chapter 7. Let's continue. I think last time I'm giving you the integration by parts. I'm giving you the e with power of negative x and then cos x dx, okay? And as I mentioned, okay, because these two elements, okay, with e and cosine, if we derive or integral, there will be repeatable as long as you want, right? E is still E, cosine becomes sine, cos, right? So if you want to use the way that I taught you before, it's called the DI method, or it's a simplification of the integration by parts. You can do, for example, first you choose the e with the power of negative x as d, and in I you can choose the cosine x, okay? And adding plus there. We derive this, we get this. We integrate cosine becomes sine, okay? And then we try maybe one more line. So we derive this. It's going back to the original part, okay? When it's going back to the original part, okay, you stop here, okay? You stop here. You stop on this line. And this will be minus cosine x. And we cross this, and multiply the last one, okay? Okay. And then remember that the concept is from this integration by parts. Okay. So actually what we did is we are just taking this down and we are multiplying this and plus and minus, okay? But because we can have this pattern here, then we can write down as the table, as this table here. And we can write down the formulations become and then minus and then minus should be plus, but it's multiplied by minus, so it's minus e with power negative x cos x dx. And it has the same functions as the original. Okay, so we can put it here. That is, we can have this 2 and then you can have half, or you can write down factorize e. And don't forget to plus at the end. Okay. Okay. Let me give you another, maybe a few examples on integration by parts. Okay, this one is the tangent inverse, okay? Tangent inverse or arcus tangent. Arc tangent. Don't confuse the inverse with reciprocal. Okay? For example, sine inverse x or cos inverse x, it is not the same as this, okay? Not the same. Okay. Now, if we are just thinking on what is the integrations of tangent inverse, as we know, um, maybe it's better if the tangent inverse can be differentiated, right? Because we know that tangent inverse, if we derive, it will be what? 1 over 1 plus x squared, right? Okay. So I think we can make the tangent inverse as a derivable part, and the x we can integrate, right? So you can write as in a regular UV integration by parts if you want. Okay. Or if we want to look for the DI method, still okay, but not really necessary because you just stop at this line. So basically, this is just a doing UV parts. Okay? So this two method will result in x tangent inverse x. Or let me write a little bit right. So integral of tangent inverse x dx is equal x tangent inverse x, and then minus integral of x 1 plus x squared dx. Okay. Now we still have this formula on the right, right? And we can simply use the u sub, right? So, or if you are maybe confused with another u at the integration by parts, we can use any variables you want, like z, any variables y, okay? And you can use substitutions method as long as you want, okay, with other variables if you want to use subs, okay? Like I think it's this. Okay, I think not this one. Okay, the other class they have this questions that need to at least using two substitutions. But at least here, okay, if you are just writing this as like let's say z, I'm gonna exchange this, become dz, and we will have 1 over z dz, right? And this will become ln. Ln z is 1 plus x squared, or this is half. Okay, sorry, and this is over 2. So the results on integral of tangent inverse x dx is x tangent inverse x minus half of ln 1 plus x squared plus c. Okay. In your calculations, you are not necessarily just plus c here. I'm suggesting you just plus c at the very end. Okay. Okay. Okay, that's the tangent inverse. So sometimes if you use the integration by parts or using this DI method like this, sometimes if you get like maybe you don't really know what's the next after your functions, maybe you don't know for sure either integrations or the derivative, just stop first, look at your formula and whether you can finish off this one, the right one. Okay. Sometimes you need to, if it's a little bit complex, sometimes you need to do maybe 2 or 3 times here, and you can get the answer. Okay. Okay. Next one is if you're given integral of secant squared x, you know that this will be a tangent, right? Okay. Right. What is if you get a secant x? Should be the answer. Now secant x is a tricky integral. We still can solve the secant, but we need help from other element. Okay, let me show you uh, the next part. Okay, so let me write secant x dx. Okay, okay. What we know from the secant x. Okay, if we have the secant x and we want to have a derivative, this will be resulted in secant x tangent x, right? Okay. And what is if we have a tangent? We know that the tangent will result in a secant squared. Okay. Okay. So from these relations, okay, we know that if we have a secant x and then the tangent x, we can integrate this and becoming the secant x, right? And if we have the secant with the squared, we can integrate directly becoming tangent. So the idea here is how to include tangent or secant into our element here. The idea here is if we have the secant x like this, and maybe we can input the secant x, okay? So if we want to multiply something with some element here, we need also to divide by those elements, okay? So that our calculation still about the secant x, right? So let's just changing the form, okay? So the secant x, we need maybe plus the tangent x. Then we can also have another one as the bottom equation, secant x plus tangent x. Why? Because if we multiply with the secant x, maybe we will get the secant squared x that we will have a chance to integrate. And when we have secant x tangent x, we also can have a chance maybe to integrate become a secant x. So let us try doing that. So writing the x like that. So we will have okay, secant squared x plus secant x tangent x. And then the bottom one will be secant x plus tangent x dx. Okay? Now what's next? If we remember, secant x derived comes secant x tangent x. Tangent x derived becomes secant squared x. Okay, let's try using substitutions. Let's try using substitutions. Okay. Let's try to use the substitutions of secant x plus tangent x. So we will get this is becoming secant x tangent x plus secant squared x, which was very similar to the first or the top equation, right? Okay. So let's write down dx. So dx is 1 over secant x tangent x plus secant squared x du. The whole thing here is becoming 1 over u du. So this will be ln, right? U is secant x plus tangent x and then plus c. So this is the result. So the next time you are, maybe when you have calculated sum of integral, or and probably you will find some secant x, you can directly change the secant x into this ln. Okay? If you have the integral of the secant x, you can directly go there. If you forget the form, this ln, you can multiply with secant x plus tangent x over secant x plus tangent x if you forget. Okay. By solving the secant x, it's opening up to other possibility. Okay. So you can try secant cube x dx, okay. Secant 5x dx if you want. Okay. Let's try the cube first. Let's try the cube one. Let's just try the cube first. Now, the secant cube, okay, the secant cube. The idea to solve this, separate secant and the secant squared. Okay. Or maybe just secant x and then secant squared x, and then the x. And we can try the integration by parts. This is the two element that we have. If you want to try the I method, you can also try. So secant x, this will be secant x tangent x. This will be a tangent x, and then just stop until there. So we will have secant x tangent x minus secant x tangent squared x, right? And we need to solve this one. Okay, how to solve this one? If you want to try the substitutions, what's the problem? The squared is the tangent, not the secant. If the secant squared tangent, I think you can use substitution. But this is the tangent squared. Okay. How to solve this? We are going to use some trigonometric identity, okay, between the secant and tangent. Okay, so this will resulting. Okay, or let me just write the trigonometry. Okay, usually this is what I usually write if I forget, and then multiply with 1 over cos squared x. This becomes tangent squared x plus 1. This is becomes secant squared x. So I know that the tangent squared x is a secant squared x minus 1. Okay. Now, if I exchange this secant squared x minus 1 into here, if I multiply with the secant, there will be some part that has the cube, right? And we can move the cube to here. Okay. So let's do that. Okay, let's do. So equal the secant cube x dx. This is secant x tangent x. Let me write here secant squared x minus 1. So this will have secant cube x dx, and then minus or plus, sorry, secant x dx. Okay. Now we can move the secant cube to the left, and the secant x we already evaluate. Okay. So we can solve this. So the key important here is whenever you see a secant or tangent, okay, maybe you can also using this, okay, to exchange. Okay. Okay, now from this part, the next section is actually about the trigonometric integrals. Okay, there are some idea behind the trigonometric identity that can help you in solving the integrations. Okay, I believe this you can solve this. Okay, I will just leave this to you. Okay, the next one is about the trigonometric integrals. Trigonometric integrals. If you check your textbook, there are some table. You can check that out if you have the textbook. But I just want to show you some highlights. Okay, what's the important part? Okay, for example, let me just go to example that is sine 5 with power of 5x cos squared x dx. Okay. Now what we have here is we have 5, okay, at sine, the power of 5. And cos is having 2 power, right? Okay. The idea behind this is by looking at the basic trigonometric identity. Okay. So if you look at this 5, okay, to get to this 2, then we need to separate 1 sine x so that this is sine 4. Sine 4, we can use the sine squared and then square, right? Okay. Now from there, we can exchange this into sine squared x and then squared, okay? And then let me just write the cos squared x and then the sine x, okay? So we separate becomes this. So why? The question is why, right? You will see later, if I exchange the sine squared using the cos squared, okay, it will be 1 minus cos squared. If I substitute u with a cos x, I can eliminate the sign, and I can have all in u, right? So it is um, making the integrations easier. Okay. Okay. So let's do that. So taking u or taking this into 1 minus cos squared x. Let me just write this first. And taking u is cos x, and du is negative sine x dx. So we will have a minus, right? Because it has a minus sine x. This will be 1 minus u squared squared, and then this will be multiplied with u squared and then du. And I think you can still solve this better than just looking at the integral. You can solve this. Maybe we can expand this first. And we will get that this will be a minus integral of u squared minus 2u4 plus u6 du. The u squared becomes let me just write the final results. Minus 1 over 3. U is cos, so cos cube x. Okay. 4 becomes 5, and it's become plus 2 over 5 cos 5x. And then minus 6 becomes 7, so 1 over 7 cos with power of 7x. Don't forget to plus c. Okay, so one idea, okay, if you see any sine and cos, and it has some power, okay, look at which one is having odd, odd, odd one. So this is 5 and 2. So the 5 one we need to separate, and we can exchange the u for the even one, right? So actually, I'm not really telling you that you need to remember all of this, okay? But what you need to look for is the pattern, okay? The pattern. You see the pattern when you have a sine, cos, maybe the other example is having the cos is having the odd. So what you need to do is just changing that, and maybe the u substitution will be the sign. Right? A similar example. And I don't think the table on your textbook really need to be memorized. I think this should be in your intuitions, okay? In your intuitions, okay? Sine, cos. Okay. This is for, let me write, this is for sine, cos, sine with power of m of x and cos with power of n of x. Case 1. Use basic identity, trig identity to rewrite the form and solve through u subs. Okay. Okay, that's the first case. The second case is we have sine cos. Of course, we have the tangent, right? The tangent squared x plus 1 is secant squared x. Okay, maybe we can start from, okay, we can start from secant, no, tangent for x secant with power of 6x dx. Oh, sorry. I think not 4. I think we start from 5, 7, and then the other one is 6, 4. Well, let's have these two questions. Okay. Now, what you remember on sine, secant and tangent? Okay. What do we remember? Okay. So if we want to have a good way to substitute, we need to remember the secant. Okay. The secant, if you derive, this will be a secant x tangent x, right? And a tangent, if you derive, this will result on secant squared x. Okay. Now, what will this do to our two examples here? We need to find a way to separate tangent, to separate secant squared or secant x tangent x, so that when we have u, we try to find du, we can cancel this. Okay. So we have two. We have 5, 7, and 6, 4, the power, okay, power of tangent and secant. Now, if you look here, this is an odd number, right? 5, 7. So if we try to separate secant and tangent from this tangent 5 and secant 7, the power will be even. In which, if the power is even, we can look at this. We can exchange the tangent squared into a secant squared or secant squared to tangent squared, right? Okay. So that's the idea actually. We need to take this part into a even number. So we need to take this into a 4x and secant 6x. And we have a secant x, tangent x, and then the x. Now, to cancel the secant x, tangent x, we need to have u is secant x, right? So we need to exchange the tangent into secant, okay? I hope this is the process very reasonable, okay? So the tangent 4 here is actually from the secant squared x minus 1, right? And then squared. If you look at this, the trigonometric identity, okay? So we can write this as secant squared x minus 1 and then squared, and then secant with power of 6x and then secant x tangent x. Now this will become using secant so that we can cancel the secant tangent. So du will be secant x and then tangent x. Yeah. So we can have integral of u squared minus 1 squared u6 du. Okay. So we can have a little bit expansion first. So let's solve this first. So we will have u10 minus 2u8 plus u6. That's integral. So let's integral. U10 become 11. So 1 over 11. U is secant. So let me write secant 11x minus 2 over 9. This is secant 9x. And then plus 1 over 7 secant 7x plus c. So plus c. Okay. Okay, that's for the first part. The second part, if you have this tangent with power of 6 and power of 4. Okay. So for tangent and secant, if you see those two, okay, you can think to substitute u or substitute tangent. So when you substitute, you need to remember, you need to separate either secant tangent x or the secant squared x. Okay. So if we are looking at this tangent with power of 6 and secant with power of 4, if we separate the secant tangent, it will be an odd, right? The power is odd. So maybe not that way. So probably we need to separate the secant squared, right? So we can separate the secant squared, and because they're all already even, then we can exchange, right? Tangent squared and secant squared because we have the identity. Okay? So because we want to substitute tangent to cancel the secant squared, we need to change the secant squared become 1 plus tangent squared. Okay. So we will have a tangent 8x plus tangent 6x, and then multiply with the secant squared x, and we can use u is a tangent x, and du will be secant squared x dx. And I believe you can solve this by yourself, right? You can solve this. Clearly, this will be u with power of 8, u here u with power of 6, and the last secant square will be cancelled, and you can integral easily. Okay. 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 Any questions? Let me give you some time to process all of this. Okay. And the next one is still trigonometric integrals. So we have the sine, cos, and tangent secant relations. Now, how about if we have integral of sine squared x dx? If you use the if you have the x squared, you get the 1 over 3 x cubed plus the x, right? Um, this is not the same way when you have the trigonometric. Okay? The better way, or the safest way to solve this is to exchange this sine squared into the double angle formula. Okay? The double angle. The double angle. Do you remember the double angle? The cos 2x like this. Or if you have the cosine also, you can use this. So it's better to exchange the sine squared into the cos 2x. Okay? Because you can integral easily the cos 2x, right? Okay. So if we have this, then the sine squared will be half of 1 minus cos 2x. So our integral, or let me write here, our integral of sine squared x dx is half integral of 1 minus cos 2x dx. And we can integral easily. this become x minus sine 2x over 2 and plus c. Don't forget the plus c. Okay. Now what will happen if I squared this sine squared? Okay, so sine with power of 4. Um, the solution is similar. So if I have power 4, then I will have this, but it's squared, right? Okay. If I have 4, okay. Okay. So let me write here. Okay. This will be from this and then squared, right? And then the x. Okay. And the sine squared, we know that the sine squared is going to have half uh, half and then 1 minus cos 2x and then squared. Okay. And then the x. We may need to expand the form. Okay. So this will be 1 minus 2 cos 2x plus cos squared 2x. So spend some time to solve this. And we get this is 1 over 4. Let me just factor out. So this will be 1. Okay. So 1 minus 2 cos 2x plus cos squared 2x and then the x. Okay. We got another one here. It's cos squared 2x. Same way, using the double angle. So we will have another 4x. Okay. So we may get uh, the cos squared dx, cos squared 2x is half 1 plus cos 4x. Okay. And use this to exchange this cos squared 2x. Okay. So we will have 1 over 4, 1 minus 2 cos 2x plus, okay, this is half 1 plus cos 4x. And then the whole thing you need to integrate by respect to dx. Okay. Now we have, let me just multiply first. 1 plus half is 1 plus half is 3 over 2 minus 2 cos 2x plus cos 4x over 2. The whole thing dx. Sine 4x divided by 4, so over 8. And plus c. I think we just stop here. Okay. So whenever you have a sine squared, you have a cos squared, it is better to exchange into double angle formula. Okay. Okay. Lastly, there another trigonometric method that you can also think is, let me write the identity first. If you have sine A cos B, okay, if you remember, this is half sine A minus B plus sine A plus B. Oh, this is B. And if you have sine A sine B, this is half cos A minus B plus, sorry, minus sine, and then the cos A cos B. No, this is plus. You can also use this part. Okay. So whenever you find like maybe integral of sine 4x cos 5x dx, you can exchange to the this product identity. So you have half sine minus x 4 minus 5, and then plus sine 9x, and then dx. Sine minus x, remember that is the quadrant 4 in the trigonometric, so it's become a minus, okay, minus sine. So this will be, let me put half outside, negative sine x plus sine 9x. So we can integrate this. So half sine integrate become negative, and multiply with negatives, it will be positive. So it will be cos x. Sine become negative, so it should be cos 9x over 9, and then plus c. Okay, one more part about trigonometric. This is it's called the trigonometric substitution. Okay. So maybe I will like giving you more techniques, okay, more and more techniques, and maybe at the end of the very lesson of the all the techniques, I will review and giving you more examples. I think a better that way. So it's called the trigonometric substitutions. So the idea behind this trigonometric substitution is basically we need to substitute variables with trigonometric functions. And what is our consideration? Okay. First is you need to remember the first one is the sine squared x plus cos squared x is equal 1. The second one is the tangent squared x plus 1 is secant squared x. Okay. So if we try to look at if sine squared x is 1 minus cos squared x, or cos squared x is 1 minus sine squared x, and the same with the secant and tangent, then when you have this 1 minus something here, maybe a variable in a maybe a fraction or in a complicated forms, we can exchange with the uh, the trigonometric functions. Okay, so for example, let me just give you the example how to use this. By looking at the 1 over x squared, and then this is x squared minus 9 and dx. Now we have, okay, the one that needs to be highlighted is this part. Okay, something squared minus 9. This is a constant minus a variables, right? So probably this, probably this. So if we know that the tangent is a secant squared x minus 1. So it starts to look similar. Okay, it has the squared here. Okay, it has a constant. Okay, so maybe if we try to substitute the this x, okay, with another variables, let's say, it's the same x. Let's just use a theta, okay, to differentiate. Okay, so let's write this. So let's substitute with secant theta here. Okay, if we just use secant theta and then squared, it's just a secant squared, but it has 9, right? If we have 3 secant theta squared, it has 9 secant squared theta. In which, if we are going to rewrite back and change to the tangent, we can do that, right? So, example here, if we let this x, okay, as 3 secant theta is our x, okay, then the, let me write here, the bottom will be 9 secant squared theta minus 9, and this will be 9, and this will be secant squared theta minus 1, or it's just as a tangent squared, and we can remove the square root, right? So that's the idea. We need to remove the square root, okay? And the next part is we are doing like the substitution method. We try to find this derivative, and we are going to somehow try to find how to cancel the other element. Okay, so derive this. This become 3 secant theta, 3 secant theta, tangent theta, and then dx. Okay, so our dx becomes this. Oh, sorry, I forgot the d theta. Let me write the d theta here. So our integrations become, this x is 3, so 9 secant squared theta, and the square root of 9 tangent squared is 3 tangent theta, so I will write 3 tangent theta, and the x become 3 secant theta So let me write 3 secant theta tangent theta, and this will be d theta. Okay, now we can cancel some parts here. Okay, so we can cancel this 3 tangent secant. Okay, now I have 1 over 9. 1 over secant is cos, right? So integral of cos is just sine. So sine theta is, what is theta? Um, we need to remember that this 3 secant theta is x. So bring our triangle. Okay. So whenever you have a trigonometric and you need to rewrite in algebra, looking back here, 3 secant theta is x. So secant theta is x over 3. And secant theta is cos theta 3 over x, like that, right? So we will have a theta here and 3 and x. Okay. The other part will be x squared minus 9. So from here, our sine is this. So we can write this in terms of our solutions, x squared minus 9 over x plus c. Don't forget the plus c. Of course, this means that every trigonometric functions you have learned and you have know, you need to be familiarized, and in order to get in, like for example here, using a theta. Okay, so if you get the sine theta, it's not a really correct answer because the question is asking in x, right? So you need to exchange the theta form back to the x. Okay? And my suggestion is just use the triangle. Use the triangle. So whenever you find something, usually something square root like this, maybe inside it has like a quadratic, either minus or plus. Maybe one suggestion is maybe using the trigonometric substitution. But of course, you can try under other methods too. What I usually suggest is try substitutions, regular substitution method first. If you cannot find any element that to be canceled, then you need to try another one. Maybe integration by parts. You still cannot separate which one is u, which one is dv. Then maybe you can try this trigonometric substitution. Okay. Okay, this is the case one. Okay, case one. So I think I hope, okay, I hope we can finish, and I can spare one day to review and maybe preparing a final exam. I think that will be better. So one day, like the whole day will be, I try to collecting questions like maybe from last year, last 2 years, and also maybe finding another questions that maybe the difficulty will be similar with your final exam, and you can have more preparation. And I also can also asking your TA to give. So I'm telling the TA to give some questions related to uh, the difficulty on the final exam. Okay. But for now, I need to explain the concept first. Okay, the concept first. And I think I've given you some practice from the textbook. At least the textbook is to familiarize first how to solve it. That's just as just an exercise. Exercise. If you can find another, maybe in the website, like questions from, usually there is like a tutorial, right? Like a tutorial, you can try to follow and see whether the difficulty is suitable for you or not. Okay. Okay. I think, oh, we can have one day to review. Okay. Okay. So this is the case one. Okay. Another case. Let me just give you an example. Okay. So rather to give you some concept that I think if you read the textbook, uh, I don't feel that students will eager to follow all the textbook. At least the textbook gives you some guidelines. Okay. But how to apply, it depends on the students. Okay. You can choose which way you prefer. Okay, let's start with the x cubed. This is a 9 minus x squared. Okay, this is case 2, the x. Case 2. Let me add my sticker. Seems everyone seems tired. Me too, actually. I'm tired too, but I try to explain this. Yeah, I don't know, since yesterday, I don't feel like really, really, yeah, feel a little bit tired. Okay. Okay, now we have a constant minus a variable. Okay. Remember from the previous one, like a sine squared or cos squared, we can have 1 minus sine or 1 minus cos squared, right? So maybe we can use that in our substitutions here. Okay. You can try to use the cos, or you can try to use the sine. Let me try use the sine first, and maybe you can try cosine in your home. So try to maybe using the 3 sine theta. If we try to derive, this will be 3 cos theta d theta. Okay, so that's our dx. Then we can exchange all x with 3 sine theta. So this will be 3 with power of 3 is, well, let's just write 3 sine theta with power of 3. Okay. And 9 minus 9 sine squared theta. Okay. And this will become 9 cos squared, right? Or eventually it got 3 cos theta, right? So this will be d theta is what, 3, dx is 3 cos theta, so 3 cos theta d theta. Okay. So this is from dx. So let's try calculate a little bit. So 3 sine theta cube. This will be 3 cos theta, 3 cos squared theta. Okay. Oh, 3, 9, right? Should be 9, or 3 squared. Okay, 3 cos theta multiply 3 cos theta from the dx part, right? So 3 power 3, 3 power 2, 3 power 5. Let's just factor out. And this will be sine. And this will be resulting on cos squared theta. Or we can, let me write in terms sine cube theta theta. Okay, if you remember, this is the beginning of our class. We have sine, it has odd, right? It says cos squared, okay? So we can separate the sine, and we have sine squared, cos squared. The sine squared, we can use this 1 minus cos, right? Okay, so we can write down the sine cube. It become 1 minus cos squared theta, and this is cos squared theta, and the sine, let's just write here. Okay. Now, if we have this, then we can simply use the substitutions, regular substitutions. We can take u in terms of cos, and we can cancel the sine for its derivative, right? Okay. So take the u as cos theta. So du is negative sine theta theta. So it will be 3 with power of 5. So this will be 1, or we have minus, right? Minus because of the minus sign. So 1 minus u squared, and then sign already canceled. We have du. And we can calculate this. And we can have this is negative 3, 5, right? I want to have a positive in front. Let me exchange this. So 3, 5, 1 over 5 cos 5 theta minus 1 over 3 cos 3 theta. Okay, now before we finishing the solutions, we need to go back to look at the triangle. Where's my triangle? So remember that the x is 3 sine theta, or sine theta is x over 3. So take this triangle, and this is theta. Okay. Sine theta is x over 3. So the other one, the other sides will be 9 minus x squared, right? So our cos theta will be square root of 9 minus x squared over 3. So let's exchange all through. Okay, you can just stop until here. Although, if you look at this form, you can simplify it, right? This is 3 with power of 5. We can cancel this, but you can simplify. But I think if you, in the exam, if you stop here, still get full point. Because the calculation is not really a calculus, right? Okay. So as long as until here, I think that's okay. The calculus part is the technique, right? The technique to integral. If you want to maybe look at how simplified it is, this will cancel this, right? So this will be 1 over 5, 9 minus x squared, 5 over 2 minus, it's 3 becomes 3, and then it has 9 squared, 3 over 2 plus 3. But either way, still full point. This is case 2. Okay, case 2. So case 2 is when you have a constant minus some variable x squared, some variable squared. Okay. Now we have the case 3. Maybe any questions first? Okay, any questions first? Any questions? Okay. So case 3 is, let me give you example, x cubed we have a variable and then squared and then plus 9. Well, sometimes this type of questions, if you can use the substitution method, the regular one, for example, if this is maybe 3, this is squared, I think you can substitute, right? Because it will be, the cube here will be getting squared and then can cancel the part on the top, right? Okay. For this one, we have to remember what kind of trigonometric that has something squared plus a constant. Okay. I think that will be a tangent, right? Tangent squared plus 1 is becoming a secant. Okay. So we can, looking at the tangent. So tangent squared x plus 1 is secant squared. Okay. So if we let the x become a tangent, in this case, we need to have a 3 tangent theta because of the constant 9, right? So dx will be 3 secant squared theta d theta. This will be our dx. Okay. Now this will be 3 tangent theta cubed over this part becomes 9 9 tangent squared theta plus 9, and the dx become 3 secant squared theta d theta. Okay, now let's simplify this. Tangent squared plus 1 is secant squared, so this will be 9 secant squared theta or 3 secant theta, okay, for the bottom one. So the whole thing becomes 3. Let me just write like that. This is 3. Let me write this is become 4. And then secant squared theta, and the bottom one is 3 secant theta. So we can have this. Okay, forget d theta. So we can look at our equations now is tangent cube secant. We need to remember the relation between tangent and secant. If we have an odd and odd, then we need to separate secant tangent. The purpose is we want to have this in even. Okay? So if we have tangent squared, we can exchange the tangent with the secant, right? Okay, like the first one at the beginning. So 3 with power of 3, 27, let's put outside. The inside one is become tangent squared theta, and then secant theta tangent theta. Now this tangent squared is secant squared theta minus 1. And let me put a little bit left here. So of course we have a secant tangent that we might use u as a secant. We will have du is secant theta tangent theta d theta. So we will have 27. This will be u squared, right? U squared minus 1 du, and it's I think it's very simple. We can have 27 1 over 3 secant cube theta minus secant theta, right? And again, this is, we are going to look at the triangle. Our case is x is equal 3 tangent theta, or tangent theta is x over 3. So this is theta, this is x, this is 3. Then this will be x squared plus 9, right? Square root of x squared plus 9. Now from here, we get the cos theta is 3 over this, or a secant, then the secant is square root of x squared plus 9 over 3. Okay, we can exchange the whole thing becomes 1 over 3 9 plus x squared over 3. This is cube minus, okay, and plus c, don't forget plus c. And then you can simplify it if you want. Okay, I think this will be the end of the class today, up until here. Okay. We still have at least two, I think two more sections. The first one is about the partial fractions. This other one is about the improper integral. Still in chapter 7. Still in chapter 7. So I hope we can finish by next week. And on the first week of January, maybe we'll have 1 or 2 classes. I think two classes before the final exam. Okay, before the final exam. Okay, and yeah. Yeah, I think I will give you either in a class and maybe this week maybe I will upload some video, okay, for some parts, okay? Maybe solving some problems. Uh, if I have time, maybe I also add some suggestions for because some of you will go for makeup exam, right? So maybe some suggestions. Okay, I think that's it, and we will have a feedback time for a while. Okay? So let me stop the presentation. I think just two questions. I hope you can join and see whether you can solve the problem or still have some trouble. Okay. And if you have other schedule for the final exam, like maybe for other course, if they already fixed the schedule, can you let me know? Because as I mentioned, maybe we will have about the either from 10 to 13 or maybe 10 to 14 from those days. Yeah. I think some of you already buy some the ticket, right, to go back home, right? Okay. Okay, I think we can start. Okay, we can start. Uh, okay, let's start. Okay, three, two, one. I hope I. Okay, I think I give you enough time. I hope 4 minutes is sufficient. So you don't need to write the pi. No need to write the pi. Okay, I hope the time is okay. Is it difficult? Okay. It seems you need to use the shell, right? The shell method. It is the parabola like this, and you need to rotate to y-axis. I think you need to use the shell method. Okay. 35, 35, okay. 34. You can use any device. You can use calculator if you want to check the graph. It is just a feedback, okay, to help you more familiarize with the question. Yeah, you can draw the graph. At least draw the graph. Look at if you want. Yeah, I think like this. Okay. Yes, it's 8. Somebody got correct. I don't know how many got correct. Let's look. Okay, only 2 students. Okay. 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 Hashtag save calculus credit. Okay. Okay. Okay, get ready. This is just 2 questions. Okay. The last question. I hope it's clear on your screen. Okay. Yeah, around 4 minutes. You need to use integration by parts. I think difficult, right? Difficult? Is it difficult? Difficult? Okay. So you can try to guess the result of the integration. Guessing. Yeah. Not guessing the answer, but guessing the result. The integral result, not the answer, but the result of integration first. You can try some functions, and when you derive, you have to have that looks right. If there is something in below that has squared, maybe you can try some function. Okay, 10 seconds. Okay, 3, 2, 1. Okay, okay. Okay, I would like to know who's your daddy. Okay, I would like to know your student ID. Okay, okay, I got it. Okay, for those of you who want to uh, scan the QR code, okay, let me stop this and let me close. And if you need the QR code, okay. Okay, see you next week. Okay, see you next week.